Assalamualaikum warahmatullahi wabarakatuh. To my panel today, Encik Mohamad Mazwan and Dr. Nor Afifah. Today, I would like to present my PowerPoint slide on final year project proposal titled Analysis of Oblique Fins to Enhance Heat Transfer. Before that, I would like to give a big thank you and appreciation to my supervisor, Madam Rozlan binti in guiding me to success of my final year project proposal from zero. There are 4 contents that I will elaborate more on my final year project proposal, which are project summary, background of study, methodology, and expected result of my project. First section is project summary. Firstly, a heat sink is a heat exchanger that transports heat from electrical or mechanical device to fluid medium, typically air or liquid coolant, where it is dissipated away from the device, allowing temperature management at optimal levels. Hence, this project will concentrate on enhancement of heat transfer through designing heat sink with oblique fins under free convection and will be analyzed using CFD simulation. The heat sink will be designed in CAD program SolidWorks and the findings will be compared to experimental results from prior study, and the heat transfer enhancement will be calculated and analyzed. Second section is background of study. Heat sinks are type of heat exchanger that are used to cooling electronic equipment because of its ease of manufacture, low cost, and heat dissipation dependability. The heat sinks extended surface are either flat plate fins or pinch fins forms. Electronic power sources aren't always as efficient as they should be, resulting in excess heat that could harm the device performance. As a result, heat sink has been incorporated into the design to dissipate heat. The demand for effective heat sinks with reduced size and weight has increased as electrical and mechanical devices such as cooling equipment, compressor, and electronic equipment have advanced. The excessive heat created by this equipment has become a big issue that might lead to component damage. From that, by increasing the heat transfer coefficients or increasing the heat transfer area, the heat transfer rate between heated surface and surrounding environment can be increased. Using extended surface fins to improve heat transfer in different types of heat sinks is useful approach techniques that is strongly used. This current project aims to analyze and design the different geometry of heat sinks that will enhance the heat transfer. Literature review. In heat sink is commonly utilized as a heat dissipation component in electronics, air conditioning, and many cooling systems. There are several factors influence the heat sink's performance, such as the fin's shape and profile are significant factors to consider when designing them. Plate and pin fins are thought to be the most cost-effective and easy to manufacture option. There are two types of fins. Plate and pin fins are the two common types of fin from studies that I have researched. By offering more surface area for heat transmission, heat dissipation via fins or extended surface considerably increases cooling performance. To that, there are two modes of heat transfer. There are natural convection and forced convection. The motion of fluid in natural convection is generated by natural force such as buoyancy effect caused by potential difference between warmer and cooler fluids, while fluid movement aided by external force is a forced convection. In oblique fins, which context to my project, oblique fins are secondary channels on the planet surface that are cut at an oblique angle to form the design of heat sink. It is considerably improved thermal performance while causing minimal pressure drop. Common problem that occur in heatsink or microprocessor design in electronic device is the advancement in packaging technology that led to smaller electronic device associated with higher and more concentrated heat flux, which lead to formation of hot zones that can cause component overheating and shorten the lifespan of electrical device. That's why many studies had done to alleviate the problem by redesigning the heatsink. It is to boost the heat transfer rate of the device by the shape or size of the fins which can be modified. Some study is still required to build more effective heatsink with high transfer rate while simultaneously reducing cost of production. These project objectives are developing new design of rectangular oblique fins, analyze the heat transfer characteristic and performance of rectangular oblique fins, and validate the simulation results with experimental results from the previous study. Scope and limitation. CATIA or SolidWorks software will be used to design the heatsink with oblique fins with reference to previous study parameters or dimension. Investigate the heat transfer characteristic and performance of rectangular oblique fins. The heatsink will be modeled and simulated using ANSYS Workbench. Simulation result will be validated with experimental results from previous study by comparing parameters. Generally, the goal of this project is to improve heat flow in microchannel heatsinks by using rectangular and oblique fins of varied angles in natural convection. The focus of the investigation is on the impact of fin type on heatsink, heat transfer rate, and surface area. However, the limitation that prevent this project is the lack of data such as boundary condition to apply on a CFD simulation on ANSYS from previous study. Section number 3, Methodology. Process flow of this project is shown using flowchart to give general view of this project. Problems starting from problems identification, literature review, SolidWorks designing, CFD simulation, validation simulation results with experimental results from previous study, and if it is satisfied, and it will be conclude, and if it is not satisfied, it will be restart at SolidWorks designing. The flow of the design process are as follow. Parameters for both heatsink are get from previous study, and then design is made for straight fins heatsink and oblique fins heatsink at SolidWorks, and then both design is import to ANSYS Workbench to proceed with CFD simulation. SolidWorks is used to generate the heatsink by referencing to past experimental research parameter. This project will use suitable material for heatsink that are good conductor of heat. Two suitable materials which are copper and aluminium, where copper is better for thermal performance, however it's very costly, while aluminium is require less cost but defeat in terms of thermal performance. InASYS is suitable tools to use in this project because of its ability to conduct research on multidimensional stream and heat move in variety design of application. The simulation model's input are defined by boundary condition. The velocity and volumetric flow rate of fluid determine how it enters and exits the model. Last section is expected result of this project. There are three expected results of this project. First, heatsink with oblique fins is more effective than with straight fins, where the average temperature of oblique fins heatsinks can be decreased due to more contact of fluid and surface of fins. Second, the Grashof number will indicate the ratio of buoyancy force and viscous force acting on fluid by both design of heatsink. Last expected result is the fin effectiveness is increased for oblique fins basically because of greater ratio of perimeter and cross-sectional area. I think that's all from me. Thank you to panel for spending your time for my slide and my video. Any question can contact my contact information below. My email mahr0713@gmail.com and my number 013-428-8991.